Okay, so we're going to be solving the polynomials. When I see a trinomial where the degree is twice as big as the middle term, I try to factor it like a quadratic. It doesn't always work that way, but I still try it anyway. In the worksheet, they ask you to state how many complex roots it's going to have. So this one has 4 complex roots because the degree is 4. So I'm going to go ahead and try to factor. So factors of negative 36 that add up to negative 5 are negative 9 times 4. So that means x minus 9 times x squared plus 4. So this one factors further. This is x plus 3, x minus 3. And this one, if we're keeping the factors in real numbers, this is as far as we go. But then when we solve, x is plus or minus 3, and then for this one, x is plus or minus 2i. Okay, because you set it equal to 0. Like that, and then take the square root. So you get plus or minus 2i. Now when I get a, a cubic function with 4 terms, I see if I can factor by grouping. And so what I do is I set up a little 2x2 grid like this, x cubed, and just put the terms in order from in standard form, from highest degree, oops, forgot the 1, and minus 20. So the greatest common factor in this row is x squared, so I take it out. And then something times x squared is x cubed, so that would be x. And then something times x squared should give me 3x squared, and that would be 3. And then something times x should give me negative 14x. And that would be, oops, not writing, negative 14, right? Now since this times this does not equal this, I know that this method doesn't work, okay? So I'm going to have to do the P's and Q's. Now since I have a lot of factors for number 2, I'm going to set up the synthetic division like this, like you see on the screen, where the leading coefficients are up here, and then I'm going to start off with 1, okay? So you bring down the 1, then 1 times 1, so you're doing 1 times 1 is 1, plus 3 is 4. And then 1 times, again, this 1 times 4 is 4, minus 14 is negative 10. Then 1 times negative 10 is negative 10, minus 20 is negative 30. So this one doesn't work. So I'll try negative 1. Bring down the 1. 1 times negative 1 is negative 1, plus 3 is 2. 2 times negative 1 is negative 2, minus 14 is negative 16. And negative 16 times negative 1 is 16, minus 20 is negative 4. Okay, so that one didn't work. We tried 2. Bring down the 1. 2 times 1 is 2. 2 plus 3 is 5. 5 times 2 is 10. 10 minus 14 is negative 4. Negative 4 times 2 is negative 8. Negative 8 minus 20 is negative 28. Try negative 2. Bring down the 1. 2 times negative 1, negative 2, plus 3 is 1. 1 times negative 2 is negative 2, minus 14 is negative 16. And negative 16 times negative 2 is 32, minus 20 is 12. Okay? Then that one didn't work. 4. Bring down the 1. 4 times 1 is 4. 4 plus 3 is 7. 7 times 4, 28. Minus 14 is 14. 14 times 4 is 56. Minus 20 is 36. Okay? Negative 4. And so bring down the 1. 1 times negative 4, plus 3 is negative 1. Negative 4 times negative 1 is 4. 4 minus 14 is negative 10. Negative 10 times negative 4 is 40. 40 minus 20 is 20. Okay, so that one didn't work. 5. Bring down the 1. 5 times 1 is 5. 5 plus 3 is 8. 40. 8 times 5 is 40. Minus 14 is 26. So this one's going to be way too big, right? 26 times 5 is 100 what is it, 130, minus 20 is 120. We try negative 5, bring down the 1. Negative 5 plus 3 is negative 2. Negative 5 times negative 2 is 10. 10 minus 14 is negative 4. And negative 4 times negative 5 is positive 20. 20 minus 20 is 0. So finally, there it is. Now this is a quadratic that does not factor. So we have to use a quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's 2 plus or minus the square root of 4 plus 16, and that's 2 plus or minus the square root of 20. Now 20 is 4 times 5, so the 4 comes out as a 2. So it's 2 plus or minus 2 radical 5 over 2. And notice how they're all divisible by 2, so the roots are negative 5, and then I factor a 2 out, and I get 1 plus or minus radical 5 over 2, so the 2's cancel, so you're left with 1 plus or minus square root of 5. So I have 1 real and 2 imaginary. So here's another cubic with 4 terms, a cubic function, so I'm going to set it up and see if this works out this time. So 2x squared, 3x minus 6. Greatest common factor in the first row is x squared. X times x squared is x cubed, and then negative 2 times x squared is negative 2x. The next times 3 is 3x, and then 3 times negative 2 gives you negative 6, so this works. That's a relief, okay? And so this is what the factors look like. So for the first factor, we say x equals 2. For the second factor, it's plus or minus square root of 3i, or I square root of 3, whichever one. So this one has 3 complex roots because the degree is 3. One of them is real, 2 of them are imaginary or complex. Alright, so here's another one, fourth degree, where this degree, let me just point to it, this degree is twice as big as this degree, and it's a trinomial. So I want to see if there are factors of 45 that add up to negative 14, so negative 9 times negative 5 work. So this one has 4 complex zeros altogether, this polynomial, so I have x squared minus 9 times x squared minus 5. And so for the first factor, x is plus or minus 3. For the second factor, x is plus or minus square root of 5. 2 real, well actually 4 real, 2 of them are rational, these 2 are rational, and these 2 are irrational, but they're all real. Okay, so here's another one, another trinomial. Factors of 8 that add up to 6 are 4 and 2. So x squared plus 4 times x squared plus 2 is 0. So for the first one, I get x equals plus or minus 2i, because the square root of 4 is 2. And for the second factor, you get plus or minus the square root of 2i. Okay, for number 6, very similar to the previous 2 problems, you've got negative, it's positive 6 and negative 3, that adds up to 3 and multiplies to give you negative 18. So x squared plus 6, x squared minus 3. So for the first factor, x is plus or minus the square root of 6i, and for the second factor, x is equal to plus or minus the square root of 3. So 2 imaginary and 2 real zeros for this one. Okay, so number 7 is the difference of 2 cubes, and you guys have to be able to recognize them when they show up randomly like this. So this is difference of 2 cubes, so the first factor is x minus 1. The second one, you square the first number, change the sign. x times 1 is x, and then you square the last one, positive 1, equals 0. So for the first one I get x equals 1. But for this one I have to use quadratic formula because it does not factor. So x equals negative b, negative 1 plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's negative 1 plus or minus 1 minus 4, negative 3 all over 2. So then the roots or zeros are 1 and negative 1 plus or minus I square root of 3 all over 2. So 1 real and 2 imaginary. Okay, so here's another 4-term polynomial. Oops, that's a cubic. I think I messed up. This is a square, and this is a cubic right here, a cube. So I'm going to set up the little 2 by 2. So this is x cubed, 3x squared, minus x minus 3. So I take out the greatest common factor here, which is x squared, and then something times x squared is x cubed, that would be x. Then something times x squared is 3x squared, that would be 3. And then something times x, so something times x is negative x, that would be negative 1. So negative 1 times 3 is negative 3, so that's correct. So my factors are x squared minus 1 and x plus 3. So from the first one I could factor it further, x plus 1, x minus 1, and then x plus 3 I just copy down. So the zeros or the roots are plus or minus 1 and negative 3. All of them are real. Okay, another one, I'm going to try the 2 by 2 grid. I put in the terms in standard form in order as they should, as they are. And greatest common factor in this row is x squared. Then x times x squared is x cubed. Then negative 2 times x squared is negative 2x squared. And then x times negative 3 is negative 3x. So then you check negative 3 times negative 2 is 6. Yes. So then your factors are x minus 2 and x squared minus 3. So the roots or the zeros are 2 and plus or minus square root of 3. So they're all real numbers. No imaginaries on this one. So even though this is not a cube function, I'm still going to do that because it's 4 terms. So I'm going to see if I can factor it like this. And again, it doesn't take a lot of time to check it and test it out. And if it works, great. Saves you a lot of time. So the greatest common factor here, greatest common factor here is x to the 4th. So I'm going to put x to the 4th right here. And then something times x to the 4th is x to the 6th. That would be x squared. Something times x to the 4th is negative 2x squared. That would be negative. Okay, so the next thing you do is ask yourself, what times x to the 4th gives you negative 2x to the 4th? And so that would be negative 2. And what times x squared gives you negative 4x squared? The answer would be negative 4. 4. And then negative, and just double check, is negative 4 times negative 2 positive 8? The answer is yes. So your two factors are x to the 4th minus 4, x squared minus 2, and you set them equal to 0. This way you could factor some more, so this is x squared minus 2, x squared plus 2, x squared minus 2 equals 0. So for the first factor, which is the same, you're going to get the same zeros from here and here, it's plus or minus square root of 2. And for this factor, you're going to get plus or minus radical 2i. So 2 real and 2 imaginary.